Hello and welcome to your last week here. Basically, these three problems throw everything together from Chapter 7, and they're a little bit difficult without an example. So I just wanted to go ahead and go through probably the most difficult problem, or number 5 right here, you see. Alright, so let's go ahead and first read it. Kevin is an auto mechanic. He spends 2 hours when he replaces shocks on a car and 2 hours when he replaces the brakes. He works no more than 42 hours a week. He routinely completes at least 2 shock replacements and 6 brake replacements a week. If he charges $500 for labor replacing shocks and $250 in labor for replacing brakes, how many jobs of each type should he complete in a week to maximize his income here? And then we want to answer, of course, then the number of shock jobs or replacements, and then the number of brake replacements here. All right. So the first thing, whenever you're working on these, is you want to go ahead and define your variables here. All right. Now, in this case, since we're talking about the number of shock replacements, we'll go ahead and call that S, and the number of brake replacements, we'll call that B. Now, of course, basically the process in these is we want to come up with a number of inequalities that represent the constraint based on this business situation. After we come up with those inequalities, we'll come up with a feasibility region, and then finally, after we get that feasibility region, we're going to go ahead and maximize an objective function. But let's not get ahead of ourselves. Let's first come up with those constraint inequalities here. All right. So for the first constraint inequalities, I'm going to base it on the fact that he works no more than 42 hours a week. And we're told that it takes 2 hours when he replaces a shock, or shocks, and 2 hours when he replaces the brakes. So from that, we can say, well, 2 times the number of shock replacements, that's going to be the total time spent on shocks, plus 2 times the number of brake replacements, well, total time spent on brakes. That means this right here is going to represent the total time he works on both those. And since we're told that is no more than 42 hours a week, that's why we say that's less than or equal to 42 right here. Alright, so that's probably the most difficult part right there. That's our first inequality there. The next one here, we're going to base it on the fact that he completes at least 2 shock replacements. Well, if S is going to be the number of shock replacements, we know that that has to be at least 2 or greater than or equal to 2. For our last inequality here, we want to say that B is greater than or equal to 6 because, well, he completes at least 6 brake replacements. Alright, so I mentioned before that now that we came up with our constraint inequalities, what we want to do is go ahead and graph them to find a feasibility region. Alright, so let's go look at that now. Again, what we want to do is find a feasibility region right here. So first thing we want to do is, well, we don't have just a normal XY axes. Our axes have to do with S, the number of shock replacements, and B, the number of brake replacements. So I'm going to create that axis. Alright, I put the S on the horizontal, B on the vertical right here. Quick note, just with this grid I used, I labeled these in 2s, not 1, so just be aware of that. Alright, so got that down. Next thing, of course, is I want to go ahead and start graphing my inequalities here. My first inequality was the one based on the amount of time he had each week, or 42 hours. And, of course, I want to shade on one side of the inequality, so here we go. We want to shade below that. Next up, we want to go ahead and graph our second inequality, or the one based on the number of shock replacements in a week. And we know that has to be greater than or equal to 2, so we'll shade everything to the right of that. Alright, finally, our last inequality is that the number of brake jobs has to be greater than or equal to 6. So above that line or right there. Now, of course, the whole point was we want to identify this feasibility region, and that's this area where they all overlap right here, right? If that's not clear enough, let me shade it all in for you here. All right, so that's our feasibility region right there. Now, back to the original problem. The whole point of coming up with this feasibility region is because we want to identify the corner points of it, because that's how we're going to figure out what the maximum value is of our income or our objective function. All right, so next thing we want to do is identify corner points here, corner points of the feasibility region. Corner points, you guys know, or hopefully, are just the corner points right here. Since our feasibility region is a triangle right here, we have 3 different corner points. All right, so that was the whole point of all that, and of course, we need to go ahead and remember those corner points right here, right? All right, so back to the question that we're asked, right? We want to figure out how many shock replacements and how many brake replacements we want to do in each week, and we just figured out different combinations for the feasibility region here. All right, so now it's time for us to figure out our objective function right here. And our objective function, we're going to say that Z represents the income, and that's our objective function right here because we're interested in income. So since we're told that he makes $500 on each shock replacement, well, 500 multiplied by S, the number of shock replacements, would be his income from that. And then since he makes $250 on each brake replacement, well, 200 multiplied by that. Oh no, I just realized I made a huge mistake right here. That guy right there should have been 250, right? Because we got a 250 right there. Oh man. So gonna have a little bit of issue for the rest of this video, but hopefully we'll follow along here. All right, so just to be clear here, let's see. Yeah, issues. All right, no choice but to continue on here. All right, now the whole point of getting that objective function right there is that we're going to use the corner point theorem to figure out where we're going to maximize it, right? Or we want to figure out the maximum income, right? So once again, we identified our corner points, right, as sorry, right there, and sorry, I got the corner points right there. Sorry, I was covering it up right here. So put down 219, 26, 15, 6, right? And then the whole idea is we want to go ahead and evaluate our objective function, or the income based on each of those combinations of shock and brake replacements. All right, once again here, all those 200s right there should be 250, right? And because all those should be 250, then also actually these numbers are incorrect. So just keep in mind those are technically incorrect, but actually we end up getting the right answer on this. So just going to keep going on it. All right, so continuing on here, it looks like, of course, our maximum profit right here is going to, or sorry, our maximum income is going to be achieved at 15 shock replacements and 6 brake replacements, right? So, of course, that's going to be our answer, and bam, we're over. And I'm going to go ahead and post a corrected version of this